Well, good morning, everyone. My name's Simon Gray. I'm the Chief Executive of EGA, the East of England Energy Group, and welcome to this fourth in our series looking at career opportunities in the energy sector. This time we're considering other forms of generation in the whole energy transition debate, looking from how we move from hydrocarbons to clean energy generation. I'll be starting in just over 5 minutes. So bear with us to get yourself a cup of tea or coffee. Sit down, make sure you're all fully prepared in front of your laptop with a notebook and pen, and hopefully I'll be able to introduce all our speakers to you in just a minute. What I would ask you to do throughout this presentation is if you can turn off your microphone and your camera so that we can preserve the bandwidth to make sure that everyone gets, hopefully, a good experience from this presentation. And I'll be back with you in just a couple of minutes. Thank you. Good morning once again, ladies and gentlemen. My name's Simon Gray. I'm the Chief Executive of EGA, the East of England Energy Group. Delighted to have so many of you with us today. This is the fourth in our series of Armed Forces webinars, looking at career opportunities in the energy sector. And this time we're focusing in on the other forms of generation in the whole energy transition debate, looking at how we move from hydrocarbons into the clean energy agenda. What we'll be looking at really is where the opportunities are, the types of roles that can be considered. It's not just about engineering. There's HR skills. There's all sorts of other areas, marketing and so on within the energy sector as well. So it's not just about engineers, although of course we're very keen to find quality engineers as well. Today's series of presentations are brought to you by EGA, our Skills for Energy programme, the Ministry of Defence, partnering with Right Management, Department for Work and Pensions, Renewable UK and Vattenfall. We also have speakers today from NSAN, that's Nuclear Skills Academy, National Skills Academy Nuclear, APITO, Oil and Gas Technology Centre, Orbis Energy, Vattenfall, and our own Gemma Head from Skills for Energy. We'll be starting the presentation in just a couple of minutes. I would ask is that if you can please all turn off your microphones and your cameras so that we can preserve the bandwidth. And at the end of the session, there will be a Q&A. What I would ask is that if you can post any questions you have within the chat area, that would be wonderful. Any questions that aren't answered today, we'll try and come back to you with answers to your points later on. So do post your questions in the chat area. And we'll be starting in just a couple of minutes. Thank you. Well, good morning, ladies and gentlemen. My name's Simon Gray. I'm the Chief Executive of EGA, the East of England Energy Group, and I'm delighted to welcome so many of you joining us today for the fourth in our series of Armed Forces webinars. As I said, it's the fourth in the series, and this time we're looking at career opportunities in the energy sector, this time considering other forms of energy generation in the whole energy transition debate that's currently going on. So we're looking at how we're going to move from hydrocarbons to clean energy generation for the future. We're looking at where the opportunities are, the types of roles that are being considered within the energy sector. And this series is brought to you by ourselves, EAGER, one of our main programs, Skills for Energy, the Ministry of Defence, partnering with Right Management, Department for Work and Pensions, Renewable UK and Vattenfall. And I'm delighted to say we have a number of skills and expert speakers for you today who will join a Q&A panel at the end as well. If I could ask you all to make sure you turn off your cameras and your microphones throughout the presentations, this just helps preserve the bandwidth to ensure that everyone hopefully has a good experience from the presentation today. And as I say, later on, we will be answering questions, we hope. So there is the chat function there where you can post your questions. So if I can have the next slide, please. As I say, please make sure your video and microphone are turned off at all times. That just makes sure that everyone hopefully can see and hear what's going on. Please use the meeting chat. And you can see we've indicated where that is. Click on that and you can ask your questions within that. As I said, we'll try and answer any questions at the Q&A session at the end. If we run out of time, what we'll then do is try and answer those questions for you and post those on our websites and other areas where you can access them. We'll also be recording the webinar as well. So if there are things you want to refer back to later, you can then go through the recording and have a look at particular sessions that you think are relevant.
Unknown participant is now joining.
And, you might get that noise every now and again. That's when someone's coming on via a telephone, and we'll have that little voice pop up there. So don't be confused by that. It's perfectly normal. If I could have the next slide, please. Great stuff. So first of all, I'm going to be having a quick look with you at how traditional generation fits within the future energy need as we talk about energy transition. So this is how we're going to be moving to net zero for carbon generation by 2050 and how we're going to achieve that. So I'll touch on that. We'll then be looking at the nuclear industry. We have our colleague Doug Harrison from the National Skills Academy for Nuclear looking at what's happening in the nuclear sector in the UK. Then Jill Glennie from Peter will be looking at the future of oil and gas. Obviously, a major transition in that particular sector as we see decarbonisation taking place. We'll also be looking at carbon capture and storage, a technology whereby you can capture the carbon produced by generating electricity or other things and be able to then store that carbon. EMPs from Orbis Energy, we were looking at opportunities from an incubating company there that's looking at small businesses and SMEs and how they're growing within the energy sector. And then we have a case study from Steve Barnes of Vattenfall. And as I say, at the end, we'll be having a question and answer session. So as I say, please post your questions in the chat area. And if I can just remind people to turn off their microphones and cameras throughout. So I can have the next slide, please. So some of the challenges and the solutions that we're looking at in relation to the energy sector. In June 2019, the UK announced a target zero for generation of carbon by 2050. And there's Chris Skidmore there, the minister at the time, signing legislation that committed the UK to a legally binding target of net zero by 2050. And we were the first major economy globally to actually announce that. So a pretty major transition for all of us as we see different generation methods moving from burning coal to gas and other things. And I'll come on to that in just a second. So next slide, please. Here we're seeing that just during lockdown, announced in June 2020, I think during April and May, we had 2 months where we burnt absolutely no coal whatsoever to generate electricity. So a major transformation to our whole economy there. And we're gradually seeing that. And if we move on to the next slide, we'll then see, well, what is generating? It's certainly in my youth, I remember coal being the major generation method for electricity. And we've all seen cleaner skies and cleaner air quality during lockdown. And this gives you some sort of idea of where our energy is coming from currently. So this was a screenshot I took from an app yesterday. And as you can see, no coal was burnt whatsoever yesterday. But 45% of our electricity that we generated came from burning gas. Nuclear and wind both came in at about 18%. and solar came in at about 3.5%. So that gives you an idea of the sort of transition that's happening. Burning gas is a far, far cleaner method of generation than burning coal. So it's really great to see how we're gradually transitioning. But we now need to work out what we're going to do. If we're going to stop burning gas, or if we are going to continue burning gas, how can we do that more cleanly? And I guess we'll be hearing a little bit more later on that from our speaker from the Oil and Gas Technology Centre, Neil Wilkinson, will be talking about carbon capture and storage, which will be a key element if we want to continue burning hydrocarbons. If I could have the next slide, please. So as I said, we're gradually getting rid of coal as a method of generation, but what will replace it? Gas has been a major transition for us. We have two major terminals, one in Scotland, one in the UK, sorry, one in England, which also it means that we also have interconnectors to mainland Europe. Gas is still plentiful. There's still plenty of gas around, both indigenous within the UK continental shelf, but also via the interconnectors that come in right the way from the Netherlands and from our colleagues in Norway as well. We also have massive opportunities in nuclear. We have nuclear new build capacity in my region, both at Sizewell and Bradwell, where we're looking at a large potential for new build nuclear generation. Renewables are gradually bringing in more and more in terms of our supply. And we're looking here at both onshore and offshore wind, also other areas such as biomass, and obviously areas such as solar. We won't be talking that much in relation to hydro, because we don't have that many hills or mountains in the east of England, but that's another area of major generation for the future as well. Something else that's being considered now is hydrogen, the generation of hydrogen. Hydrogen can be a very, very clean fuel. Hydrogen can be burnt, and the only thing it generates is water. So the lovely thing about that, it's a very, very clean method of generation. However, currently it's quite expensive to generate hydrogen, but there are different ways being looked at now in terms of being able to generate hydrogen much more cheaply. And lastly, we need to consider energy storage. One of the other areas that needs to be looked at is how we can effectively store energy when we have too much of it. Quite often, particularly with offshore wind and solar, we're generating energy that isn't being used. How can we store that energy better? Some of the questions that are gradually emerging. I think that's the end of my presentation, if I remember correctly. So I'm now going to hand over to some of the opportunities that this will also create. So I think one of the key points here is that the UK is at the very forefront of carbon reduction. We're leading the world on this, and that obviously means that with world-class companies in the UK, it gives us opportunities for export. I think you'll find other nations beginning to emulate and develop what we're doing here globally, offering opportunities globally for future careers as well. And then hopefully people will go away to other countries and then come back to the UK and where we can benefit from their skills. So we'll be looking at things like carbon capture and storage, onshore and offshore wind, hydrogen, and today we'll be considering some of those alternatives and reflecting upon the possibilities for development, job creation and employment. And at the end, as I say, we'll have our panel of expert speakers who will be able to assist you in that. I think I'm now handing over to Doug Harrison from National Skills Academy Nuclear. Doug, over to you.
Thanks, Simon. Morning, ladies and gentlemen. It's great to have the opportunity to talk to you today about how nuclear energy sits within the energy mix. I have 8 minutes, but could obviously talk all day about nuclear, but I'm sure those following me wouldn't be happy if I took more than my allotted time. If you have any questions, please, as Simon said earlier, please use the chat area as we go along. Next slide, please. So just a quick note on who NSAN are, as I'm sure that quite a few of you will not have heard of us coming from the military. So NSAN is the go-to place for skills for nuclear. We are not nuclear skills. We'll leave that to the professionals, the EDFs and the Magnoxes of this world. We were a membership organisation led by nuclear sector employers from both civil and defence and right across the sector to provide valuable, cost-effective and practical support to organisations large and small. Next slide, please. So discussion points today. I'll talk about nuclear within the overall UK energy mix, but I would like to focus on what is happening in the industry at the moment with some very exciting projects that are currently going now and also in the pipeline for the future, as I'm sure you'll want to know where your skill set sits within the nuclear sector. But just a quick note that I sent the presentation to Esme on Friday morning, and since then there's been a couple of new developments. On Friday afternoon, the government announced a further £40 million package of funding to help develop the next generation of nuclear energy technology. And an open letter from scientists and engineers has been sent to the Prime Minister to emphasise the need for new nuclear and how the projects will help people get back to work and improve the economy as we recover from the pandemic. Next slide, please. So let's begin with looking at the energy mix. Nuclear power is often referred to as the baseload electricity. The amount generated can be increased or decreased depending on the amount of electricity being produced by other low carbon or renewable sources. And you'll see there about the strike price for Hinkley. Everyone says that nuclear is expensive, but when the strike price for Hinkley was agreed at £92.50, offshore wind was sitting at 140. But obviously, as the technology is getting better, then that price has come down dramatically. Studies show that the repetition effect is the same for nuclear, so that's what we're hoping on that. And that's known as the fleet effect. And Hinkley Point C, which is already showing innovative ways of cutting costs, which will be transferred over to Sizewell C. Next, please. So wind, solar, and energy storage can get as much of the way to the carbon-free future, but we need nuclear in the mix as well. As it says there, over the past 50 years, use of nuclear power has reduced CO2 emissions by over 60 gigatons. And without new nuclear, will not hit, as Simon said earlier, we will not hit net zero by 2050. Next, please. We need a stable energy supply, and nuclear will allow us to achieve this alongside other forms of electricity production. However, the biggest barrier to new nuclear at the moment is mobilising that investment. And one of the ways that we're looking at that is we're waiting for the energy white paper to be published. But obviously, over the last year or so, delays due to Brexit and COVID-19. Next, please. So even though we have virtually stopped, as Simon said earlier, stopped burning coal to produce electricity, which is a good thing, we still rely on burning gas to produce over 50% of our electricity. Current and future low carbon forms of production are necessary to bring this figure down further. The link here will give you a live idea of what is being used at the moment. And on a cloudy, calm day in Norfolk, the link shows a live picture of the UK electricity generation, and I have that up as of 10 o'clock this morning. Gas, 52%, as Simon said. Nuclear, 16.7%. Wind is 10%, and solar is 8.6%. And obviously that would change as the weather patterns change. Next slide, please. So now turn our attention to current and future projects within the nuclear sector. As I say, 8 minutes is not a lot of time, but I have shown links to each of the projects that I'll cover in the next slides, where you can find out a lot more information. Starting off with the nuclear sector deal, it's now 2 years old, so we have a way to go to achieve the targets that are said there. And as I said previously, Brexit and COVID-19 have not helped. Next slide, please. This is an old slide, but shows where the nuclear new build sites were agreed to be built. Hinkley Point C is obviously underway, and its sister station Sizewell is obviously is in the planning stage. We have Wolf and Ewart in Wales, Mooside up in Sellafield, Bradwell in Essex, and Albury in Gloucestershire. Next, please. I'll just briefly go through each of the projects. Leave it on the screen, but you'll get a lot more information from the slides there. So as I mentioned, Hinkley Point C, Sizewell will be a copy of HPC, and you will have read planning consent has been applied for. This goes for the 30% reduction in nuclear new build as part of the nuclear sector deal, and that's already being looked at from transferring the lessons learned and bringing tier 1 contractors over from Hinkley. But on any of these projects, we're not just talking about main engineering roles. It's everything across the board. You're looking at HR, finance, health and safety, catering. Hinkley Point C have set up a consortium of local catering companies called the Somerset Larder. So I'm sure that would be something that would transfer quite well across here. Next, please. Bit of a delay. Bradwell B, a nuclear power station in Bradwell in Essex, has been progressed by joint partners CGN and EDF Energy. Wilford Newid on the island of Anglesey. It was postponed in January 2019, but they have put in for their planning, and they're looking, once we get a better way of financing these without relying on foreign investment, then I'm sure that will go forward. Next slide, please. Bit of delays hadn't to my time here. So this is a new one. This has been coming about over the last couple of weeks, and I'm sure that you will have seen this in the press. It's over the Mooside Clean Energy Hub. And that link there is a very good way of a good presentation on that. Then move on to the next slide, which we'll talk about nuclear small modular reactors. And whilst the UK has lost the ability to produce reactors for larger stations, SMRs can be built in factories, and is envisaged that UK manufacturing will produce the majority of the components. Moving on to nuclear fusion, which is on the next slide. This is a quote from Boris Johnson when he announced some major funding with regards to nuclear fusion. So the picture shown is the Joint European Torus, or the JET, which opened in 1984 at Culham in Oxfordshire, and it's the world's largest operational magnetically confined plasma physics experiment. Next slide, please. Just coming to the end now. And again, major investment in fusion, £220 million of government funding. Starts to look at the next phase, which is the spherical tokamak for energy production, and part of that they're building a new plant at the Advanced Manufacturing Research Centre in Sheffield. And the next slide just shows a typical fusion power station, how it could look like and what it's got there is three of the step. And then the next slide is the largest, it's the International Thermonuclear Experimental Reactor. It's in Cadarache in southwest Spain. 35 nations involved in the build and operation of this, and the experiments that are taking part at JET are feeding into the development of that. Moving on to my last item, which is the Geological disposal facility. So permanent solution is needed to the storage of UK nuclear waste, and I was on a webinar last week, and interesting to see that a lot of coastal communities have shown interest in siting one of these, the GDF, as they see that the GDF can be built underneath the sea. Next slide, please. And this shows that the GDF is a 100+ years project. So we're not talking about construction in 15 to 20 years time. We are still at the initial actions. And then lastly, just talking about net zero, which if you can click it again for me, I'll bring it up. You can read that, and Simon did talk about it, but really net zero needs nuclear. And I'd just like to finish on one quote from someone high up in the industry who has the ear of government. So if you just click it one more time for me, please. Just click. Next slide. That the UK needs to double the current nuclear new build to reach its target of net zero by 2050. So finally, on the last slide, I'd like to thank you for listening. Apologies for the delay with the slides, and I'd now like to hand over to Jill Grenny from Apito, who's going to talk to us about the future of oil and gas.
Thanks very much. So good morning, everyone. I'm Jill Glennie. I'm the Director of External Affairs with APITO, and it's great to be with you today. Firstly, an introduction of who we are. So APITO is the global not-for-profit skills body for the energy industry. We develop and deliver training and competence products and services to ensure a safe and skilled workforce. We also establish and run programmes to attract, develop and retain the workforce of the future. And this includes our OGTAP apprenticeship scheme, which has been running for more than 20 years. We've been around for more than 40 years, and APITO has transformed into a global organisation, and we operate in more than 50 countries. So we don't carry out training directly. Instead, the training is delivered through a network of more than 200 accredited and independent training providers who deliver training to APITO standards. So just to give you an idea in terms of numbers, last year more than 375,000 energy workers were trained to APITO standards. And just a reminder, if you just joined us, please feel free to ask questions at the end. If we can go on to the next slide, please. So in terms of future skills demand, as Simon mentioned, we're living in a period of unprecedented change, and this includes a transformation across the energy system. In terms of industry dynamics, our industry was recovering from the previous downturn, and it's now facing a further prolonged period of low oil price. We've got some larger operators leaving the industry, and new, more nimble organisations focusing on late life asset management in oil and gas, and they're entering. So technology, data, digitalisation, we'll hear more from OGTC, is transforming how we work, and this has dramatically increased, obviously, as we've all been in lockdown over the last few months, and of course the energy transition driving net zero. And so this means that the future skills demand is changing. And last May, APITO launched our second report on the UK's oil and gas industry skills landscape. And here's where we see the key changes from 2019 to 2025. And that's from oil and gas to wider integrated energy, and from incremental technologies to transformation solutions, and from a UK footprint to an ever-increasing international reach, and from tried and trusted models to new innovative business models, and from an oil and gas workforce to increasingly multi-skilled people. So that's very much talking about an energy workforce. And all of this creates an urgent need to reskill and upskill the workforce. If we go on to the next slide, please. And so the application of new technology will enable far more adaptable and agile work environments. And that's in contrast to the more traditional sort of matrix type organisations. And just a sample of the array of roles that are great for inspiring the next generation. We've got 3D material scientists, work gamifiers, avatar relationship managers even. And there's a combination of the real-time data analytics and artificial intelligence will need more insight and decision-making deeper into the organisations. But there's still a significant need for the traditional skills in terms of mechanical engineering. So you say it's not just that, it's communications, engaging with people, safety, coaching, planning, skills that I know you'll all have in an abundance. And just from my background, I joined APITO a year ago, and over the past 12 years, I've worked with 4 oil and gas operators, with colleagues who have left careers in the military and joined those organisations, working both on and offshore. So I've worked with submariners who've become OIMs and ops managers, planners and security advisors who've become directors and VPs of HSE, medics, mechanics who have left the Navy and have been in their absolute element working on the FPSOs, which are the floating production and storage vessels that work basically in the same way that the platforms do. And what's evident is that the teams will need to be more flexible and nimble compared to what we've seen in the past. If we can move on to the next slide, please. And so when we published our report last May, we highlighted that new and innovative ways of learning and development will emerge. And again, over the last few months, the need for that has progressed at speed. APITO is collaborating with industry and our training providers to ensure that the industry has access to the right skills. Improved collaboration will help the curriculum and training methods to adapt more quickly to the changing demands of the energy transition and enable a real focus on lifelong learning, so learning for all ages. And the combination of new technology, machine learning, AI and expert systems, alongside the new training methods, which is computer-based training, virtual or augmented reality and simulation, will really transform and is transforming how people are learning and gaining new skills. And it also means that people can acquire new skills and competencies and can transition into other sectors in a shorter time. And again, during the lockdown, we've seen substantial change to existing training provisions across even our approved training centres. And we've worked closely with them to enable them to deliver training digitally, and this will continue. And final slide, please. So in terms of, I've mentioned the reports that we've done, and the next stage for us is using those 2 research reports to bring the broader energy industry together. And we've established the Energy Skills Alliance. It's very much a cross-energy effort with support from governments, representatives from oil and gas, EGR, renewables, nuclear, onshore, the OGTC and unions, to really drive focus and action. So bringing our findings from the reports into action. Our aim is to create an integrated skills strategy for the net zero industry. And it's timely and crucial as we look to restart the economy, focusing on jobs and skills. Just briefly, I'll overview the work that's already underway in each of the 4 areas. Firstly, we've got future energy skills demand and supply, which is key obviously for today. And that's looking at creating a cross-energy picture of skills demand and supply, both in the short and long term. And this work will identify urgently the key gaps and opportunities to support and enable skills transfer into and across the energy sector. Secondly, there's the Integrated STEM programme, and that's an online resource for exploring all avenues of energy careers, primarily built around interactive community and sharing personal stories to encourage younger people to join the industry. And all energy apprentices. So more than ever, there's a real focus on sustaining and growing apprenticeships, all energy apprenticeships, and again, for all ages. There's no upper age limit for our apprenticeship scheme. And we need to develop and train energy people, skilled and qualified people who can work flexibly across the energy sector. And there's a real opportunity to create the pipeline of talent that we need to deliver that energy transition. And finally, looking at the all energy training and standards, this is looking at the growing skills demand in offshore wind, hydrogen, carbon capture and storage. And it's a huge opportunity to align the training and standards to simplify the framework for employers and workers themselves. And it's vital to support people at every stage of their energy career and those moving from other sectors to energy, and to support flexible opportunities across the sector. So just to summarise, like every industry, we don't know what the new normal is going to look like, but we are working together to establish this urgently. What we do know is that alongside the new skills, there's still very much a demand for what we might call the traditional skills. And we know that the how people want to learn and the what they're learning is changing. And the energy industry is working together to make that transition to different sectors more accessible to all. So with that, I'm going to hand over now to Neil Wilkinson, who joins us from the OGTC. Thank you.
Hello, good morning, everyone. I hope you can hear me okay. As Jill kindly introduced, my name is Neil Wilkinson. I work for the Oil and Gas Technology Centre up here in Aberdeen. My personal experience, though, I'm 7 years in oil and gas. Moved into the energy transition over a year ago, first in strategy and strategic goals for the company that I worked with before OGTC. And then moving on from that into business development, and now into project engineering for the OGTC. So the OGTC are focused on enabling technology development in the oil and gas industry, but of course now quite a lot of our focus is now on net zero. And we have a solution centre which we set up last year, which is focused on that energy transition and includes everything from projects and technology, of course, in wind, hydrogen, carbon capture and decarbonisation as well of oil and gas. Next slide, please. Yeah, so this is obviously this is a picture here of 2019. Of course, it's very much the same now, and what it basically shows is a very siloed and sort of industry-specific picture. So everything you see here isn't integrated, or if it is, it's only a little bit integrated. And we have a wind industry, we have an oil and gas industry, we have onshore sort of power production, we have nuclear. A lot of these industries do talk to each other, but in quite a lot of the cases they do not. And last year you'll have seen, of course, the CCC, the Committee for Climate Change, came out with their targets for net zero for 2050, 2045 here in Scotland. And obviously, to get there, one of our key focus areas moving forward is collaboration, and that we see that as a key and critical enabler for us to reach net zero. Next slide, please. So this is actually some of the data that we pulled from the CCC report and some of our own due diligence around what it could look like from an economic point of view from now into 2050. Obviously, you see the big bubble there, 24 billion is the current oil and gas UK figures for the oil and gas industry. And then that next to that, you see wind and hydrogen and then carbon capture there at the end. And that overall equates to a £26 billion industry here in 2020. But as we see, as we move towards 2050, we're starting to see the tail off in the oil and gas industry. We are a mature market. It is slowly reducing in size. But at the same time, we're seeing a massive upscale in wind. We're seeing a massive upscale in hydrogen as well. And for the purposes of today's conversation, there's this huge upswing in carbon capture. And overall, that leads to a much larger industry than we have currently, with, of course, an increase in jobs and an increase in opportunities that are out there at the moment. So next slide, please. And I can say at this point that from our due diligence and from the information from the CCC report, the suggestions are that currently in carbon capture, there's around less than 1,000 jobs, I think, in the UK, but projections are up from 20 to 2020. Sorry, and then into 2030 and 2040 and 2050, we're seeing around about 15,000 jobs here in the UK for carbon capture. So this is a view of 2050 and how it will actually look, or like we hope it will look. And this is a much more integrated view of the UK North Sea, where industries onshore and offshore are collaboration, where demand hubs for hydrogen and electricity are satisfied from the offshore wind industry, the offshore oil and gas industry as well. And every industry is working together to help decarbonise and reach net zero. Next slide. So yeah, this more or less summarises that previous slide as well. So currently, right now in the UK, we currently require 300 terawatt hours of electricity. And then by 2050, obviously, due to the large-scale electrification, you're moving to electric cars, we're going to see almost, or well over double that. It's 645 terawatt hours of electricity. And for that, we need technology, we need policy, we need legislation and strategy. But importantly, what we need is approximately 175 million tons of CO2 storage per year, where currently we have zero. So, but there are a few projects underway at the moment, and we see a massive upscale in CO2 storage as we move forward. Next slide, please. Yeah, so just what I said a second ago, here in the UK, we have projects underway for looking at carbon capture, utilisation and storage. The one that I'm mostly involved in is the Acorn project, up here in Scotland. And in addition to that, point, look, as you can see, currently we have no storage projects in operation, but obviously we're trying to get to a stage where we're storing 175 million tons. Excuse me. But at the same time, we have a capacity. We have a huge capacity for CO2 storage here in the UK. And that presents fantastic opportunities for the import of CO2 from other countries. I know early on, Simon mentioned to us being able to export our expertise to other countries. But at the same time, we've got an opportunity here to be a hub for the storage of CO2 for the rest of the world and Europe as well, which allows us to charge them for that, of course, which is great for the UK economy. So we're seeing a carbon capture demand across all of these industries here mentioned on the right: hydrogen, power generation, bioenergy, of industry, biofuel production, and a few others as well. Next slide, please. So from a technology point of view, there actually are a number of technologies looking at carbon capture. But at the moment, there's one in particular that's leading the way, and that's post-combustion carbon capture technology. So Simon alluded to earlier on around 45% of energy production came from burning gas. So at the moment, carbon capture is very much required. And the technology that I spoke about just a second ago, post-combustion carbon capture, what that does is it processes the exhaust gases from these industries and strips the CO2 from that gas stream into another form, where it is then processed and sent away for storage. This technology uses, in most cases, a solvent, where the exhaust gas is put into one of the funnels that you can see in the top picture. And as that gas rises up in the funnel, an absorbent is also flowing down the way, and that actually, in essence, the chemical reaction and the CO2 is captured in that sorbent, and then the solvent, sorry, and then that is processed and subsequently sent forward for processing and storage. And the bottom technology is one that we're seeing developing rapidly. Certainly in the USA, where they've got a lot of requirement for, they've got a lot of legislation, and they've got a lot of tax incentives for the use of carbon capture. Direct air capture is a very, very cool and new piece of kit that's entering the market, and that's sucking carbon dioxide, sorry, purely from the air. It doesn't require any brownfield mods of any existing infrastructure. It pulls CO2 directly from the air. Next slide, please. And here's a really cool animation here of carbon capture. We're looking at onshore capture, we're looking at offshore storage and production offshore, we're looking at EOR, so that's enhanced oil recovery from CO2. And this shows you the picture of how vast, only in the oil and gas offshore industry, how CO2 storage is going to help that industry grow. Next slide. Sorry, Esme, I see that I've got about a minute left. I'm running a little bit over. Sorry, click a few times, please, as well. Thank you. Yeah, so a question was actually raised by Shane in the chat, and this slide showcases that. But sorry, back one, yeah. What we're really good at here in the UK, of course, is oil and gas, and we have existing infrastructure already in place so that we can actually effectively store and sort of transport and store CO2 at scale. And one of the, obviously you'll see in many of the clusters in the UK at the moment, Humberside, Teesside and Scotland, we're looking at decarbonising that industry and obviously helping job growth and helping the economy. So one of the areas I'm involved in is around the decarbonisation of the Grangemouth and the east of Scotland using the Feeder 10 pipeline, which is an existing pipeline from St Fergus all the way to Grangemouth. And that's an example where we can reuse existing oil and gas infrastructure to capture CO2 at Grangemouth, transport it the whole way up to St Fergus for processing, and then injection in the North Sea. And these are a number of the locations in the North Sea where we can store CO2. Next slide. And a few clicks as well. Thank you. Yeah, CO2 utilization. I'll quickly go through this. It's a growing market. Everything that you can see on the slide there on the right are all the industries that utilization is growing in. So at the moment in America, CO2 is used a lot for enhanced oil recovery. Here in the UK, it's used a lot for fuel production. It's also used in the food and drink industry, and a hell of a lot more, as you can see on the right, but it's growing at the moment. And it's building over time, and what we're seeing as this moves forward is a rapid growth in utilization and the adoption of new technologies. Sorry, Esme, I do realise that I've gone over my time, and if anyone has any questions, please feel free to ask in the comment section. And with that being said, I'd like now to hand over to Ian Pease from Orvis Energy, and thank you very much.
Hi there, and thank you very much, Neil. My name's Ian Pease, and I'm the Business Development Manager at All Energy for All Energy at Orbis Energy in Lowestoft, Suffolk. And thank you for the opportunity to talk to you today. Just a reminder to keep the questions coming into the chat area, and hopefully we'll be able answer some of those at the end of the presentations. Next slide, please. So in terms of an outline today, I'm just going to quickly skip over the opportunity and talk a little bit about Orbis Energy and the regional picture, and then move into a little bit more focus on Suffolk as a region, really just as an exemplar and an opportunity that can be crossed into other areas, and then hopefully we can draw some conclusions from that. Next slide, please. So here's Orbis Energy, and this is the region's clean energy business hub located in Lowestoft at the most easterly point in the UK. Established in 2008, and it provides a home to some of the region's leading clean energy businesses and organisations. We also provide a unique location for energy innovation and incubation at the heart of the UK's renewable energy sector. We recently welcomed the Offshore Renewable Energy Catapult as a tenant to Orbis Energy, and that's headed up in the east of England by Andy Holyland, who himself has transitioned successfully from the military to the energy sector and is an advocate for the armed forces, and very willing to talk to you about his transition into the energy sector. Next slide, please. So here's the snapshot of the energy asset that you should all be experts in now after these recent suite of seminars. So the headlines: 52% of the UK's offshore wind is operational in the east of England, currently around 4.6 gigawatts. But by up to 2030, that could be as high as 15 gigawatts and looks like something like 1,700 turbines. So our region is the UK's largest offshore wind cluster. We also present and produce 30% of the UK's domestic gas requirements for the UK. And as Doug mentioned, 1.2 gigawatts of operational nuclear power at Sizewell B, with Sizewell C and Bradwell on the horizon. We are a clean all-energy region. Next slide, please. So just to give some context here, 2050 UK net zero targets have already been talked about, but one thing that sometimes isn't mentioned is the 2030 climate emergency that was declared by local authorities. And what this did in effect was bring forward those net zero targets from 2050 to 2030. So creating an awful lot of challenge and but also opportunity as well. And very much more recently, last Tuesday, we heard from the Chancellor of the Exchequer a plan for green jobs. And part of this was the Green Homes Grant and around £2 billion worth of funding, £5,000 per household, which is looking to create over 100,000 jobs in the green economy and improve around 600,000 homes. This is coupled with a public sector decarbonisation programme, where there's over £1 billion of expenditure in the next year for schools and hospitals to fund energy efficiency and low carbon heat upgrades. Next slide, please. Okay, so for these figures, I've chosen to home in on Suffolk, really just to give an indication of the pace of change at a local level. And we could apply similar figures to counties like Norfolk and others throughout the UK who have a similar geography, population and location. We expect a well-documented growth in electric vehicles, and UK Power Networks predicts that by 2030 there could be as many as 105 to 178,000 electric cars and vans in Suffolk alone. And to meet the climate emergency target at Suffolk County Council, we predict we need the installation infrastructure for 300,000 private and 3,500 public charging points for those cars and vans. Now, you can see a clear discrepancy in the figures here, and they are predictions, but nevertheless, it indicates that there's going to be a big push in project planning, installation and commissioning of the electric vehicle charging infrastructure throughout the UK. If I could have the next slide, please. Once again, UKPN predicts, based on a high electrification scenario, the installation of up to 317,000 domestic heat pumps by 2050, and a further 11,000 to 25,000 heat pumps in industrial and commercial settings over the same period. This is for Suffolk alone. In terms of installation rate for Suffolk, this could look like 12,000 heat pumps installed annually from 2020 to 24, and that would then ramp up towards the 2030 target date to 50,000 per year. And the aim is that from 2025 onwards, there's no new gas boilers installed to replace traditional gas boilers. As you've learned in the previous seminars, district heating, very important, but likely to be less prominent in the more rural counties, but nevertheless, that could still look like 20,000 connections. And next slide, please. From a generation perspective, UKPN expects solar PV to be the main form of distributed generation in Suffolk, both commercial and domestic, and this represents up to a 5 times increase in solar PV by 2050. It's also really interesting to note that much of Europe's PV fleet is actually aging, and it's approaching 10 years old. So by 2025, I think 100 gigawatts of power will be over 10 years old. And there's an opportunity here around inverter repowering. And anecdotally, I bumped into a neighbour the other day who informed me that after 9 years, his inverter for his PV system on his roof has just failed, and he's had to have a new one put in. So opportunities there in electrical engineering. Okay, next slide, please. Energy efficiency is probably the most overlooked factor on our journey to net zero, yet these measures are probably the most effective and easy to implement. We'll see new incentives, increased awareness campaigns, and significant growth in the uptake of energy efficiency measures, including loft insulation. Yes, people's lofts still not deep enough, and mine is included in that. Cavity and solid wall insulation, heat controls and draft proofing improvements, and the prevalence of triple glazing windows. These figures, again, do come with a health warning, as they're based on a high case scenario for this county, but required to meet 2030 net zero targets. So they're 20 years earlier than the government 2050 targets. Next and final slide, please. So to conclude, the clean energy revolution is happening in East Anglia, and we are the all energy region, and we're leading the transition to clean energy. I think it's really important for you to consider carefully the underpinning skills and competencies which will support a range of energy technologies. Some will come to fruition and some may take a little longer, but those skills in electrical, mechanical, process, health and safety,
Hello, my screen's just frozen.
Apologies for this. I think we've lost Ian. So I'm just going to hand over to our next presenter, who's going to give us a case study on his experience from Vattenfall.
Okay. Good morning, everybody. Steve Barnes. In the absence of slides, I shall blunder through this in the best traditions of the British Army. Hopefully give you an idea that of my transition from the Army into the renewable energy industry. Inexplicably, people don't necessarily quiver with excitement when they understand they're going to be spoken to about security, but hopefully it just give you an idea that it's just one of a myriad of jobs and roles out there in this industry. I don't know if we can get any slides up, but I left school at 16, not really knowing what I was going to do, apart from the fact that I knew that I wanted to join the Army. But I went on a youth training scheme for 2 years until I was 18, did a general engineering thing with ICI, and then signed up with the Intelligence Corps. And after a roller coaster 30 years, I hung my boots up on the 1st of May 2017. I probably applied for 35 jobs or more over a 6 to 8 month period in my sort of transition and resettlement period. And I was hugely frustrated at the lack of response, sometimes lack of feedback. So concurrently, I set myself up as a consultant, as a security consultant. I immediately got a very lucrative week's work, unfortunately for me, my dreams of playing golf, going fly fishing, and working 6 months of the year on an exorbitant daily rate went out the window when Vattenfall offered me this job, having applied for it online. And Mrs. Barnes decided that paying the mortgage at the end of every month was the way forward. So what it did mean was that actually I knew absolutely nothing about the wind industry. In fact, other than thinking that security was what I wanted to do, I hadn't really applied it to a specific industry. So it meant that I had to give myself a crash course on the internet of what is it all about? What does Vattenfall do? How does it work? And how can I apply my skill set over the top of that? So what do I do now? Having been offered the job, I'm now the business area wind security officer for Vattenfall, and we work over 5 countries, and I essentially produce security risk assessments and threat assessments to try and gauge the level of security risk that a project will be exposed to during the construction period, but also throughout its operational lifespan, and then try and recommend implementation of appropriate minimum security measures. It's broader than that. It's not just the physical security aspects. There's a whole element of personnel security as well. As you can imagine, if we're proposing to build a huge wind farm, especially onshore, or a massive substation, which is going to sit onshore, not everybody leaps with joy. Some people can get fairly agitated about that, and some of that opposition and agitation can spill over into quite vociferous protest. So there's often liaison with police forces in the various regions just to make sure that anyone who really does want to take umbrage doesn't pose a risk to our people or to the public, or indeed to the project. I do travel security as well, because our people travel a lot, or they did do before COVID, and event security, because we like to crow about it when we open up a huge wind farm, get a dignitary in, and clearly we need a security plan to keep them protected. In terms of what advice I can give you, I'm not sure how well placed I am to tell you all about it. I've put down, probably the next slide, please. Oh no, this one, that's good, sorry, my mistake. I put down the first thing was networking, although acknowledging that I kind of stumbled across my job. But talking to as many people as possible in the industry to get an understanding of the breadth of roles that are out there, not a bad start point. I mentioned research as well. Trying to make sure that my CV was applicable to the industry was a bit tricky. But and I know you hear this through the Career Transition Partnership all the time, but putting time and effort into your CV, I think, is invaluable. Obviously, CTP give you advice if you're an officer, the Officers Association, but try and find people in the industry who can rip it apart for you, and with the gloves off, tell you the good bits and the bad bits. I had mine passed through a number of hands, and then it got given to an ex-soldier out in the wild who told me it was utter rubbish, and almost rewrote it. And I think that's the one that got me over the line with Vattenfall. Something that people don't tend to talk about is negotiating. We all spend all these years in the military, and nobody talks to you about how to negotiate a package. So if you can get advice from people about that, just to make sure that you don't suddenly get clobbered with commuting costs or something along those lines, but you can delicately and diplomatically negotiate yourself the best deal at interview, I would take some advice on that where you can. And take a little bit of time off after your discharge. I think I retired on the 1st of May and started work in this job 5 weeks later. and a little bit more time might have been beneficial, I think. But it's good work. I have to say, all the stuff the Army's taught me, that whole self-reliance, self-discipline, time management, etc. There are definitely skills that transfer. Your punctuality, flexibility, all the stuff that's there on the slide, and definitely a sense of humour. There's an awful lot of on the bus, off the bus, with working in multiple projects in multiple countries. But it's really rewarding, and it's part of the future. And if you get a chance to get into the industry, embrace it, as one of my slides says. That's me, Esme. Hopefully that was of some benefit to everyone. Sorry about the graphics. And I'm going to pass you on to Gemma, who'll host the questions. Thank you.
Yeah, unfortunately, everyone, it won't be Gemma. Gemma's broadband connection has collapsed. I think quite a few broadband connections have collapsed. So my apologies for some of the technical issues we're having then. This new technology is wonderful when it works. So once again, thank you to all our speakers. Really excellent presentations there. And Steve, really well and bravely fought through, considering you didn't have any slides. So well done. So we have our panel. Hopefully, all these speakers are still on the line. I have a number of interesting questions to go through. The first one that I noticed earlier on was in relation to battery storage. And the point was being asked there, I think, was in relation to vanadium redox flow batteries. Honest answer to that is I don't honestly know, and I doubt whether anyone here does know, but if they do, please let me know and please pitch in. What I would say is that virtually every form of energy storage is being looked at. Which would include, I'm sure, vanadium redox batteries as well. But we'll see what we can find out from an energy storage specialist that we have, who'll be able to answer that offline, and we'll post that a response to that up in our Q&A later on. I think there was also some questions in relation to opportunities in Scotland. I think a lot of that has been touched upon, but I don't know whether any of our Scottish-based speakers would like to comment on any of that at all.
Yeah, I'm happy to do that, Simon. Right. So I can just elaborate on the point. What's keen to note here is that there's several hubs around the UK. Humberside, Teesside, Scotland around Grangemouth, south of Wales, and some over Liverpool as well, that are looking at massive scale decarbonisation of their onshore industries that require a large amount of CO2 capture, transportation and storage offshore. And what we're seeing in that case is a massive hike in jobs around construction, carbon dioxide technology itself, transportation, infrastructure, pipelines, obviously everything that comes with that, marketing, HR, every type of industry. These are massive growth areas. So we see obviously Scotland having that with Grangemouth, and the East of Scotland project is called SNEEZR, Scottish Net Zero Roadmap. And of course, the other hubs will see something similar as well.
Thanks, Neil. Anyone else wants to chip in? Jill, are you still there? It doesn't look like it. So there's another question for you, Neil, I think, which was in relation to, for post-carbon capture, what's the ratio of input to output in relation to size? In other words, is the storage sustainable? How much can we store? And if we're going to import carbon for other nations, what's the sort of life scale in terms of the potential for storage?
Yeah, hopefully we got that, Shane, we understood your question correctly. That was my take on it as well. The storage potential in the UK far outweighs our the amount that we actually have to capture. We spoke about 175 million tonnes a year. I can't remember the exact figure in my slide, but we're talking gigawatts in terms of size of storage. The only thing we have to consider, of course, is the propagation of gas from those reservoirs up into the higher layers of soil and then into the ocean. That's a key point we need to consider. Of course, this is not natural gas and it's not oil. So we need to ensure that, first of all, the offshore site is modelled correctly and that it has the right structure with regards to whether it has the correct cap rock so that CO2 can be stored safely and securely for generations. So we definitely have the storage capacity, and we definitely have that potential to start charging other countries to store it. Yeah.
So talking about cap rock, so this is a layer of rock over and above the actual cavity that's there that will be holding the carbon, and this is to ensure that can't escape through that rock.
Yeah, exactly. Yeah, so CO2, natural gas is stored within the pores within a rock itself, and you have a layer of rock above that that's a lot more dense, and therefore there's no propagation of gas through that rock. That's called cap rock. But CO2 is completely different and can actually travel further through rock than natural gas can. So there's a lot of modelling still required, although we can lean on the oil and gas industry to get some of that information as well.
I think when it's under pressure, does it turn into a solid, or does it remain gaseous?
I think that's about the extent of my knowledge, but
right.
Being a mechanical
unknown participant is now exiting.
So
great stuff. And I don't know whether Ian, are you back online or not? It doesn't sound like it. The next question was someone, Ian Anderson, was saying he's really interested in solar energy and what are the best courses to get started from. We can find out more about that, Ian, and we'll post a response up there. But as an interim suggestion for you, go to the Solar Trade Association website. So Solar Trade Association, just Google that. Go to their website, and they have a lot of information about the potential roles within that. And just give them a ring or drop them a line as well, and they should be able to help out. But Ian, if you don't get any further, we'll certainly post up any responses we get on that front. And if for any reason you don't get any satisfaction via those routes, do come back to us, and we'll see if we can help out on that front as well. So we've just about gone over our 11 o'clock deadline. But I have to say, I think it was a really brilliant session. We managed to struggle through, despite some of the issues we had in some of the technology. And I just really like to thank all those that have been involved in this throughout our 4 presentations that we've had. A really successful set of webinars that really, hopefully, have been of use to our colleagues within the armed services and those that have come out and transitioned from the armed services already. Certainly, if you do have any questions as well over and above that, do feel free to send it in to Iga and to your speakers that have been here today. Do also use things like LinkedIn to make sure that you link with us and with other colleagues that have been on this call to benefit from those individual networks as well. So I'd like to thank Doug Harrison from NSAN, Jill Glennie from PETO, Neil Wilkinson from OGTC, Ian Pease from Orbis, and Steve Barnes from Vattenfall for a fantastic insight into the world of energy and its transition into net zero. Ladies and gentlemen, thank you very much indeed for participating. It's been a great morning, and thank you so much for all your questions and joining us today. Thank you very much indeed. Lovely to see you all. Take care. Bye-bye.
Thank you very much.